Algebra 1 lesson 44, and we'll look at 45 as well. But first, we are finding the slope using the slope formula. So we're looking at two different coordinate points and using the slope formula to find a slope between those. So slope, remember, is just a measure of how steep a line is. And we know some things already about slope. Things like it's the rise over the run. That's the ratio that we have. It's represented by m. It is the steepness of a line, and we have our slope formula, which says y2 minus y1 over x2 minus x1. What this is saying is that we have two different points, one that we can name x1, y1, and the second point x2, y2, and we plug them into this formula. Remember, all this is doing is finding the difference between our y value, so the rise, and the difference between the x values, the run. So it's the vertical change over the horizontal change. So let's look at some examples. If we have 7, -3, and -2, 1, well, I can name these as follows. And it actually doesn't matter which one I choose to be my x1, y1, just that it follows the pattern. If this is x1, this has to be y1. I couldn't name it y2. And if this is x2, then this has to be y2. This is my second point, my first point. And I plug them into my slope formula. So m equals, well, y2 is 1 minus y1, which is -3, over x2, which is -2, minus 7, which is x1. And so I go and I simplify. And I say 1 minus -3. Well, that becomes positive, so I have 4 over -2 minus 7. Well, I could add the opposite here or know that it's just -9. And since I can't simplify 4 over -9, I leave it like that. And that is my slope between the 2 points. Let's try it again. And we say, let's say that this one is x1, y1. This one's x2, y2. And let's plug it in. And we say -9 minus 3 over, oops, sorry, I started doing it the previous way. That's okay. I'll show you both ways to show you that it doesn't actually matter which way you go, just that it's consistent. So if we do y1 minus y2, so 7 minus 4, and we end up with -12 over 3, which is -4. And if I go the other way and do 3 minus a -9 over 4 minus 7, we end up with 12 over a -3, which still ends up as a -4. So it doesn't matter which way you go, just that you are consistent. If you start with one and find the difference to the other, you have to go the same way. All right, let's try another one. Find the slope, 2, 4, and 6, 6. So I'm going to do 6 minus 4 over 6 minus 2. Remember, y's go on top, x's on the denominator, so we get 2 over 4, which is 1/2. And a second one, -4, 4, and 4, -2. So I'm going to do 4 minus a -2. And -4 minus 4, which means that we get 6 over a -8, which reduces to a -3/4. Remember, it doesn't matter where that negative goes. It can go on denominator or numerator. It doesn't matter. It still ends up a negative answer. Okay, a couple more. 0, -5, and 5, 10. So I'm going to do 10 minus a -5 over 5 minus 0, which gives me 15 over 5, so the slope is 3. And we can do -13 minus 5 over 3 minus a -6, and so I get -18 over 9, which is a slope of -2. All right. Now we can also find the slope in a table, remember? So let's try these two. And it doesn't actually matter which points I choose. If I were to figure out are these lines, then I would need to make sure that all of them do have the same slope. But in this case, we are told we know that they are lines. And so we just pick a couple points. Let's say we pick this one and this one. Doesn't matter. And so I do 6 minus a negative 12, those are my y values, over negative 5 minus 40. And so I get 18 over negative 45. I can divide both of them by 9, so I get 2 over a negative 5. And so just to prove that this is a line, we could also do something like, let's choose a couple more points, making sure that all of the slopes are the same. And we would do this for any table, however many values it takes to prove that all of the slopes are the same. So let's try the 6 and the 0 now. So we do 6 minus 0 over negative 5 minus 10, and we get 6 over a negative 15. We can divide each of those by 3 to get 2 over a negative 5, and it works out. And again, we can do it on my second table, and I'm going to pick, sure, these two, it doesn't matter. So 3 minus a negative 3 over negative 2 minus 1. And we get 6 over negative 3, so our slope is negative 2. All right. Okay, and of course you can determine the line based on the numbers. Now, it might be easier to use the numbers because, well, things like this, it may be a little bit harder to count and make a slope triangle to find that. So use that slope formula for both of these. Okay. And let's try a couple of these. So what if we had this and we said, all right, 4 minus 4 over 6 minus a negative 6, and I end up with 0 over 12. Well, am I allowed to do that? Yes, I can take 0 and divide it by 12, and I get 0. This is a horizontal line with a slope of 0. And this next one, we do negative 5 minus 1 over 7 minus 7, and we get negative 6 over 0. Unfortunately, I cannot divide by 0, and we would say this is actually a vertical line, so the slope is undefined. Okay? So just use that slope formula when you're given different points. It will help you determine the slope quite easily, actually. And let's go on to lesson 45 really quickly. So if we're translating between words and inequalities, we are going to be using a bunch of the words that we've seen before that correspond to addition, subtraction, multiplication, and division. This is where we can put all of them. We can say, all right, addition. We could say, we'll see words like sum, plus, in all. Subtraction, we'll see things like difference, minus, less. Multiplication, product, times. Division, quotient, divided by, equal groups. Sometimes equal groups can be multiplication as well, depending on how it's worded. So let's take a couple examples and figure out, well, we have some sentences. What would be a way to describe this in mathematical format? So the quotient of an unknown number and negative 2 is greater than the opposite of negative 9. Let's take this piece by piece. So the quotient, we know we're talking about a division relationship of an unknown number and negative 2. Well, it tells us the order. Whichever comes first when we're talking about it in a sentence goes on the numerator, and the second one goes on the denominator. Is greater than, well, that means I need to use a greater than symbol. And the opposite of negative 9 is, opposite of 9 is negative 9. So we should see that our answer is x over negative 2 is greater than negative 9. All right, B. 0 is less than or equal to the difference of twice a number and 8. So let's start, and we should see 0 as less than or equal to. That's pretty straightforward. The difference, so there's a subtraction relationship here, of twice a number. Well, twice a number, that's talking about multiplication of 2 and a variable. And so that number with a difference and 8. So we should see 0 is less than or equal to 2x minus 8. It doesn't matter what variable we put in. C. The number of half a number and 3 does not equal 15. So the sum, we're talking about an addition relationship of half a number. So I'm taking a number, dividing it by 2 and 3. So we're adding that to 3, and that does not equal 15. That's what we should have here. We're just translating these into sentences. And D, the product of 11 and a number is less than 121. So the product, we're multiplying, 11 and a number is less than 121. All right, so just break down these sentences and with what you know about these words, create those relationships. All right, how about if we are given some sentences or some mathematical statements and we need sentences from them? Well, there's a lot of ways to say these, but I could say for E, I could say something like, the product of 12 and a number is greater than or equal to the opposite of 8. We could say something like that, or the product of 12 and an unknown is at least negative 8. Okay, so we need something greater than or equal to negative 8. We could say for F, the product, or let's start here, the sum of 2.5 and the product of an unknown and 1.5 is less than 11.5. Or we could say the sum of the product of 1.5 and a number and 2.5 is less than 11.5. You can see there's lots of different ways to write these. Next one, 9 is greater than the product of, or let's say 9 is greater than the difference between a third of a number and 8. We could say something like that. All right, and that's pretty similar to what they said as well. And how about this next one? Let's say the quotient of an unknown and 7 is less than or equal to 8. Okay, or you could say a number divided by 7 is at most 8. So meaning that this needs to be less than or equal to 8. And I, the lowest temperature at which a piece of beef can be cooked is 140 Fahrenheit. The formula is 9/5C plus 32 equals our Fahrenheit to convert from Celsius to Fahrenheit. So write an inequality for an equivalent reading in degrees Celsius for a piece of beef cooked rare. Okay, so when we look at this, we would say it needs to be, since 140 is where we need to get, we need this part of the inequality to be greater than or equal to 140, meaning we need to get it at 141, 142, 143. So that piece of it, okay, with Celsius included, needs to be greater than or equal to 140 degrees. All right, just a couple more examples here for this lesson 45. Carol buys a large bottle of juice for $4.50 and apples for 25 cents each. Write an inequality for how many apples she can buy if she can spend no more than $15. Well, if we're talking about juice, well, we're going to do $4.50 times how many juices I have, plus 0.25 for how many apples I have. And that amount needs to be less than or equal to $15. If I go to the cash register and it's more than that, I can't buy it. Okay? And next one, last one. Jonas is purchasing 15 screen-printed warm-up suits for his soccer team. He can spend $1,000 at most. There's a setup fee of $25. What can he spend on each suit, including tax and printing costs? So we would say printing costs plus 25. Okay, and he needs 15 of those. Okay, 15 times how much it costs to actually do it, plus the setup fee needs to be at most $1,000. So it needs to be less than or equal to $1,000, or he would be over budget. Well, I hope this is helpful for your homework and for studying.